Imagine a maze. A computer mouse has to go in each direction one at a time to find the end. But a quantum mouse...
Alright, sorry buddy, gonna have to stop you right there. Wonderful content, wonderful information, but there's a very important misconception in this example that he's about to go into. Watch this, then go back and watch that video with this misconception in mind so that you can actually understand how insane all this is. But the misconception here is mostly just with the analogy. Quantum computing does not process anything in parallel. It's just like normal computing where you are performing an operation on a particular value, and all we're doing is trying to figure out the fastest and most efficient way to do it, right? Another piece of background information for this is the difference between analog and digital computers. A digital computer is a computer using binary and electricity, the one you think of as your TV or your actual computer or your phone. Those are all digital computers. Alright, I don't know how much that picked up, but, yeah, I'm new to this. I haven't actually used YouTube Shorts for this purpose before, so please, if you watch this and you have a way in the comments to just set it to 3 minutes from the start when you're remixing like this, let me know. Outside of that, though, the reason quantum computers are massive is because they are an analog computer. A digital computer makes its computations using physical interactions that allow us to perform logical interactions. It is built on Boolean logic. The idea that if this, then this. The idea that if X is true and Y is true, then etc., right? All logical arguments. Quantum computing is using physical arguments, physical operations, sorry, not arguments, where they are physically manipulating the particle in order to adjust its superposition to somewhere that they want it to be. That is the answer they are looking for. Now, can you ever get it exactly to this superposition? Probably not. Like, exactly? No. Actually, no, you can't, because quantum mechanics is inherently probabilistic, which is kind of the big deal. It's literally random. Not randomness in the way that your Minecraft seed is random, but true randomness at the very base physical levels of the universe. And quantum computing is us rigging that deck in order to gamble for the right answer. Which is why it's very selective and where it might actually be useful, but this is still a big deal. Just expect it to be more relevant for your learning your large language models than for your gaming at home.